So yesterday we looked at Ethernet, in particular Ethernet 2 protocol and IEEE 802.3 protocol. We also looked at the IP protocol, which is for the network layer. And now today, again at the network layer, we look at ICMP, the Internet Control Message Protocol. So let's see how this goes. So ICMP, it's commonly referred to simply as ICMP. So that's the acronym for Internet Control Message Protocol. It's a protocol that works alongside IP. So they work together at the network layer as a form of messaging protocol in order to compensate for the limited reliability of IP. So the implementation of ICMP is required to be understood to familiarize with the behavior of numerous operations and applications that rely heavily on ICMP in order to support underlying messaging based on which further processes are often performed. By the end of this chapter, you should be able to, number one, a volunteer, you can just unmute your mic, tell us your name and go ahead.
My name is Kenneth Kichinda.
Completion of this. Okay, Kenneth, you can go ahead. Thank you.
Upon completion of this section, you'll be able to describe some of the processes to which ICMP is applied, identify the common type and code values used in ICMP,
yes,
and explain the function of ICMP in the ping and traceroute applications.
Thank you very much. Okay. Okay. Now, generally, ICMP is used to make IP more reliable, and the purpose, one of the main purpose of ICMP is to ensure that we get feedback in case there is a problem with forwarding the packet towards its destination. So most of the time, we will send a packet in form of a message, and we will either get a reply from the destination or we will get an error message. So generally, ICMP has functions. ICMP has the following functions. So one of the first function is that it is used to report what we call diagnostic information, to diagnose the status of the network, whether there are congestions in the network and so on and so forth, as we're going to see in a short while. The next purpose of ICMP is to support routing. So we're going to see how it supports routing. And the last one is error reporting. Error reporting. So these are the three main applications of ICMP in our networks. And we can't actually manage enterprise networks without understanding how ICMP works, because ICMP will help us to troubleshoot the network actually. So these are the three main applications of ICMP in our network. So let's look at the very first one, which is routing. Now, any computer that needs to communicate with devices beyond their network, as we said yesterday, will normally have to go through what we refer to as a gateway. And most of the time in our network, a gateway is a router. A gateway is a router that is connected to that network segment. So in this particular example, we have this particular interface that is connected to this network segment, and the IP address is 10.0.0.100/24. So you can see that actually this is the class A address that we have done VLSM on. We've borrowed some host bits and made them network bits, because a class A address should be /8. So here we've done VLSM. So the other thing is here, host A also has an IP address that is in the same network as that particular interface of our router. So the IP address of host A is 10.0.0.1/24. Now, the other thing that you need to configure in host A in order for it to be able to communicate with devices in other subnetworks is what we call the gateway. And generally, the gateway is simply the IP address of your router interface that is connecting to that particular segment. So in this machine, you have to configure a gateway, as you're going to see shortly when we do our first lab. So you need to configure a gateway address. And the gateway is simply meant for this. Hey, host A, you want to talk to someone on the internet? Yes. So send that packet here. Then this guy who's called your gateway will get it to the internet. So that's the main purpose of the gateway. Okay, so we now want to understand how ICMP actually does routing, how it supports routing. So this is how it does it. Now, in this example, host A wants to send a packet to this guy, server A. As you can see from their IP addresses, these two devices are on different networks. They're on different networks. So if this guy wants to talk to host A, server A, he needs to send that packet to the gateway. And that's exactly what is happening here. So in this very first message, host A is sending it to the gateway. Now, when the gateway finds this particular message, the gateway is going to realize that, oh, but this guy who you're trying to go to is actually within our internal network. This guy is not on the internet. He's within our internal network. So what what the router or the gateway will do is that they'll do what is happening here at number 2. They'll generate and send back a message called an ICMP redirect message. So that redirect message will come to host A. And this redirect message will simply tell host A, if you want to go to server A, use this next hop. So in this message, it will give the address of this particular hop, which is 10.0.0.200. Why? Because this is the shortest distance. So we can't go looking for server A on the internet, then ndio hiyo packet irudi tena irudi ndani, ndio irudi kwa hii router, ndio irudi itumiwe server A. So really that is what is happening now in step 3. So in step 3, host A here will now create a new packet with this using this address as the gateway. And therefore, when this packet gets here, it's gonna be forwarded now to server A. So that is what we call ICMP redirect message. And that is how ICMP is used to support routing. So that's the very first function of ICMP. So I don't know, is this clear? Have you understood my explanation? Does anyone have a question?
Okay, to me it's not clear.
Okay. Who is this?
Is Ken Kichinda. Sorry, I didn't raise my hand.
Okay. No problem. I can go through it again. So this is what we are saying, that for host A to send a packet to anyone beyond their network segment, you see, this is one network segment here. We call it a network segment because all these interfaces are on the same network. You see, how do you know they're on the same network? You look at the IP address and the subnet mask. So all of them are /24, and all of them are 10.0.0. So the very first 24 bits that identify the network are the same for these interfaces. So here, host A can be able to reach this interface. He can be able to reach this interface. But anyone outside that particular network segment, they'll need to go through a gateway. They'll need to go through a gateway. In many cases, in our networks, the gateway is actually a router or a layer 3 switch. So whenever you are configuring network parameters in your end station, one of the parameters you must configure, other than the IP address, is the address of the gateway. So in this case, the address of the gateway has been configured as the address of this router here. Let's call this router RA. So we call this guy RA. We call this guy here maybe RB. So router A, this particular interface here has been configured as the gateway. So what that means is, hey, if you need to go to any network, send that packet to this router. Send that packet to that router. That's the same way if you write a letter and you want it to go to another town, you have to drop it at posta. So posta is your gateway. Now posta will deliver it to wherever you want it to go. So that's what we call a gateway. You must know where that posta is, the physical location of that posta. Then you drop your letter there. Then you don't want to know what will happen next, but posta will handle how it will get to the owner. So that's what we call a gateway. So that is what I'm saying here. In this first message here, this guy wants to send a packet to a different network. That network is this one here. He needs to send a packet to server A. So ataunda hiyo packet na atume to gateway yake. Hey, deliver this message to this guy. So huyu akiipata, huyu kwa routing table yake, we are going to learn about routing tables. In his routing table, he knows that, hey, this network is actually within our internal network. So really, you don't have to go to the internet to get this guy. What do you do? So it will form what we call an ICMP redirect message and tell this guy, hey, if you want to reach server A, use router B as your gateway, and router B will deliver your packet. So that is what is happening here. So host A will build a new message and send it to router B. Then router B now will deliver it to server A. So that is what we call an ICMP redirect message. And that is how ICMP supports routing. So I don't know, was it clearer now?
Yes, it's clear now.
Yes. Maybe I can just, I don't know. So I really don't know how posta handles their letters, But for example, if it had divided the country into provinces, so maybe we have Nairobi and then we have Rift Valley, like that. So then in every province, they have now a town that is responsible for forwarding in that particular province. So for example, for Rift Valley, maybe they have Nakuru. So if a letter comes from Nairobi and needs to go to Rift Valley, they need to forward it to Nakuru, and then Nakuru will now distribute it within Rift Valley. So this is just a scenario that I'm trying to create here. But now, if I want to send a letter, for example, to Laser Hill is here in Laser Hill. Let me just do it here. So I'm in Multimedia University. I want to send a letter to Laser Hill Academy. Laser Hill Academy is in Rongai. Rongai is in Rift Valley. So what is happening here with ICMP redirect is, logically, I'm supposed to send this letter. I'm supposed to drop it in a poster in Nairobi. Then these guys will drop it to Nakuru. Then Nakuru will drop it to Laser Hill Academy. But that's a long way. Why? Because the distance between Nairobi and Laser Hill Academy is just about 12 kilometers. If it goes to Nakuru, it has to go up to for about 200 kilometers. Then I don't know. It's just too much. So because this is the shorter distance, Nairobi will simply advise me, hey, if you want this letter to get early, then just drop it in Rongai. It's closer. So that is what is happening here in this particular scenario. So I hope it's clear. Okay. So the other main function of ICMP is what we call diagnostics. Now, diagnostics, to diagonalize a network. Diagonalize. Is that the spelling? Diago. I don't know. Diagonalize. Okay, so in diagonalizing, most of the time we look at what we call measuring delays in the network. And how do we do that? We use that using what we call a round trip time. So that's one. The other one, which is very important, is reachability. So we use what we call an echo, request packet, and an echo reply packet. So this is how we diagonalize. Reachability is, am I able to reach this particular host on the network? So in this particular example, we have host A and a server. So if we want to test whether we can be able to reach this server on the network, then we will send an ICMP echo request with the destination address of server A. Now, when server A receives that echo request, they are going to reply with what we call an ICMP echo reply. Now, that time between sending the request and receiving the reply is what we call the round trip time. And therefore, if the round trip time within our network is too high, we can actually be able to quantify that we have a delay in our network and it's taking this long. So that's how ICMP is used to diagonalize delays within our network through the echo request and the echo reply. Now, reachability. When you receive a reply, when you receive an echo reply after sending out an echo request, then it means that that particular end is reachable. That particular request is reachable. And I think some of you have tried this so far. It's called the ping application. Like on Windows, on the command prompt, you can just ping an IP address or even a web address. Like you can just open command prompt, then type ping www.facebook.com. So it's gonna translate, your DNS is gonna translate facebook.com into a public IP. Then it's gonna send echo requests. Then you're gonna get echo replies if you're able to reach the Facebook servers. So those are the two main capabilities of ICMP in regard to diagnostics. And the last part of the last functionality of ICMP is error detection. Yes, Chris?
Okay, good evening.
Good evening to you, Chris.
I have a question regarding the ping application. When you ping, sometimes you get a feedback, a timeout, and host unreachable. What is the difference?
So we are going to look into that in a short while. Hold your horse.
Okay,
Okay,
thank you.
Okay, so errors, ICMP errors. So when we send a packet, to the network, sometimes, for example, in this particular example, host A is sending a packet to this server. But this server might be down. For example, huku stima imepotea, so this server is actually not on. So when that happens, the router, these guys we are calling gateways, the last router that will be unable to reach this guy is gonna send back a certain message. What Chris was asking about, for example, destination unreachable. So meaning we've been unable to reach this particular destination IP address. So ICMP error messages are simply used to notify the packet source of problems with packet forwarding. Several problems can occur, as we are going to see in a short while. So the gateway uses the source IP address. The gateway uses the source IP address in the IP header for notification. So this guy, before discarding that packet, he's going to read the source address. Hii barua imetoka wapi? Hii packet imetoka wapi? Then he's going to send that particular person a message that, hey, we could not find this guy, with a particular ICMP message, as we are going to see in the next slide. Okay. So just like we did with the IP header and also the Ethernet 2 header, the ICMP header also has several fields, is made up of several fields. And as you can see, the ICMP header is actually encapsulated within the IP header, and also within the Ethernet 2 frame in order for it to be delivered on the physical medium. So it's important to note that. So these are some of the fields for ICMP. One of them is called the type field, and the type field is used to give the general type of message. Then the code field is used to give the specific type of message. When I talk of general here on the type field, I mean a group. So messages have been grouped into several groups, as we're going to see. Then in each group, you can have more than one message. So in the code here, we will specify a particular message type. Then the checksum field is used for integrity of the ICMP packet. Again, ICMP operates on the network layer, so it's a packet. Then we have variable parameters. These variable parameters, most of the time they are set to 0, but for example, in the ICMP redirect, the gateway will communicate the IP address of the other gateway. Yeah? So he will simply say, hey, use this guy as your gateway if you need to get to server A. So that particular IP address will be done on this particular field called the variable parameters. Okay. And that's what we are saying here, that additional data are often carried to identify the undelivered packet. So these additional data are always carried in this particular field, depending on the type of message that you're sending. We can have some additional data. So that is what happens on that particular field. Okay, so these are the particular messages. So these are the types. So we have type 0, type 3, type 5, and type 8. Then let's look first at type 0 and type 8. So these ones are the easiest. These ones are used for the ping application. Echo request and echo reply. So if the ping is successful, you're going to send a request, then you get a reply. We say that that ping has been successful. The other end is reachable. So most of the time, this is how you're going to be testing reachability in your network, using the echo, ICMP, echo request, and echo reply. So their code is 0 because in their group, we only have one message. Then the other group that only has one message is group 5 here, used for the redirects. We've already looked at the ICMP redirect. So redirect datagram for the network. Then now the last group that has 4 messages is this one here. So group 3. So in group 3, we have the code from 0 to 3. So the first one can be network unreachable. So network unreachable, for example, the gateway in that network is down. So if the gateway is down, then the message that will be returned to the source is network unreachable. Then we have source host unreachable. For example, your machine imekuwa shut down, ama NIC yake imefail, ama imekuwa configured with another address or something, so it will return host unreachable. Then protocol unreachable. Sometimes in our gateway, we block certain protocols using what we call access control lists. We are going to learn about them later. So in case you're trying to reach a particular server using a particular protocol that has been blocked, then you're going to get this reply, protocol unreachable. Then sometimes you can also block some ports using access control lists. So if you try to access a server in our network via a certain port that has been blocked, then you're going to get this error message, port unreachable. So Chris, are you comfortable? These are the specific error messages that you can get for ICMP: network unreachable, host unreachable, protocol unreachable, and port unreachable. Chris, are you good?
Okay. I was asking regarding for the ping. There's a time you can ping and you get timeout, and there's another one you can get a host unreachable. For the host unreachable, yes, nimepata ni your device cannot be, is not, yani haipatikani kabisa.
So yeah, timeout.
About timeout.
Okay, so okay, timeout ndakuonyesha sahi tu in the next slide. Bethwell, you had raised your hand. And Joshua,
I want you to repeat protocol unreachable. I didn't understand that.
Okay, so for protocol unreachable, I'm saying that sometimes in our router, remember the router is the boundary between the public network and our internal private network. So in our router, we can block certain protocols for network security purposes. So for example, we can block a protocol like FTP, file transfer protocol, meaning you cannot download files from our servers, from the public network, from the internet. So anytime you try to access any of our servers using FTP, you're going to get an ICMP reply with the message, the protocol is unreachable. So is that clear?
Yeah.
Joshua?
Okay, my question is, what type of message description comes when the TTL is 0?
sana sana network unreachable. Network unreachable.
Okay.
Network unreachable. So wakati packet imewanda kwa internet mpaka TTL ikakuwa zero, most of the time the message you're going to get is network unreachable, because it means we cannot get that router that is supposed to hand over that particular packet to its network.
Okay.
Okay, so now let's go and look at the ping. Then I can also answer Chris's questions about the timeout. So in a router, so here we are in router A. So in router A, we can be able to type the command ping. This time we've done ping, then space, then question mark. This is what is called a partial help. No, actually this is a complete help. So the complete help will list a list of options that we can enter after the keyword ping. So one of the options we can enter after the keyword ping is this one, -T. So this -T can help us to actually vary the timeout in milliseconds. And what is the timeout? Is the time to wait for each reply. So for example, the default timeout is 2000 milliseconds. So if you send a request and you don't get a reply within 2000 milliseconds, then the error you're going to get is that timeout error that Chris has just asked about. So you're not going to get host unreachable, blah, blah, blah. No. So sometimes you might want to increase this particular value from 2000 milliseconds to a larger value in case you have delays in your network. Because if you have delays in your network, then you're going to get all the time timeout. So that is what timeout is used. The other option here, -A, is used to select the source IP address. So you can be pinging from an interface with a certain IP address, but you might want to change that IP address so that you refer to a different IP address. I think when we look at routing, we can be able to give this a try much later. Then by default, we normally send 5. By default, we normally send 5 requests. But if you want to send a fewer number of requests, you can use the -C option. So -C, then space, then maybe 2, then the address that you want to ping. Then -N is when you want to have numeric output only. So no attempt will be made to look up host addresses for symbolic names. So you cannot use URLs like www.facebook.com. You only want to use the IP address. So in full, this is how we do the IP. This is how we do the ping. So ping, then the IP address of the interface you want to ping. In this particular case, we want to ping RTB at this interface here, 10.0.0.2 from RTA. So how do we know that we are in RTA? You can see this prompt here is RTA. So when we do, when we learn about VRP, we are going to learn how to configure the router and how to do the ping. Okay, so after we do the ping, we get the results. So the results will have several parts. So one of them is you're going to see that you're actually getting replies, and you're going to see that you're actually getting replies from whoever you pinged. Other than that, you're going to get the size of the ICMP packet. This by default, I think it's 56 bytes. You're also going to get the sequence. So each each reply will have a sequence number. So 1, 2, 3, 4, 5. Then you're going to get the TTL. This TTL is actually taken from the IP header. So by default, it's 255. So the TTL. So because we've not gone beyond any hop, it's still going to be 255. Then here, in this column, you're going to get the round trip time. So for example, the time between us sending the request and getting the first reply, it took 340 milliseconds. The time between us sending the second request and getting the reply, it took 10 milliseconds. And down here, you can actually get now some statistics from that ping. For example, you can say that you sent 5 packets, you received 5, and therefore you've had 0% packet loss. If you have things like delays in your network, you might get timeout for some packets, and therefore those will be calculated as a packet loss. And at the bottom here, we have other insightful statistics like the minimum time it took for us to get a reply, the average time for all the pings we did, all the 5 pings, and also the maximum time it took for us to get a reply in millisecond. So is that clear? Is that clear, ladies and gentlemen?
Yes, it's clear.
Wonderful. So the other application of the other diagnostic application is called Traceroute or Traceroute. Sorry, Traceroute. So Traceroute is majorly used for 2 purposes. Again, to find the round trip time in order to find out delays, but most importantly, to find the path via which the packet was forwarded. So in this particular example, we want to do a trace route from RTA to this destination here, to host B. So you see, from RTA to go to host B, we can either follow this path or this path. So if we follow this path, it's going to come here and then here, then finally delivered here. If we follow this one, it's going to go like that. So which path to follow is something we are going to learn about much later. But if you want to find out all the routers in your network and on the internet, routers are also commonly referred to as hops. Hops, a hop. So each router is referred to as a hop. So generally, Traceroute will give you a hop by hop, a hop by hop output of your packet. So all the hops that it passed through. So that is what Traceroute is used for. These are some of the options for the Traceroute. You can please go through them much later. So this is what we get when we do Traceroute. Traceroute. So the keyword is Traceroute, but this particular application is called Traceroute. But the keyword we use for that is, the command is Traceroute. So we want to, from RTA, we want to Traceroute this destination. So we can actually see that the first router it went through was this one with the address 10.0.0.2. We can see that the second router was that, and lastly the third router was that. So if I just go, so 10, then 20, and then 30. So if I go to the previous slide, we should see that it's actually saying that it passed through this interface, then through this, then through this. So it passed through those routers. 10, 20 network, then 30 network to get to the destination. So other than that, you can see that it also gives the time, the times it took to reach each particular router. And here, I think the TTL has been set to 30. So maximum hops for the Traceroute is 30. Yeah. Okay. So that is it about this topic. So we can have someone guide us or lead us in discussing these two questions, please. A volunteer. Is Lynn here today? Wes? Wes? Oh, Lynn, naona umeunmute mic yako.
Okay.
Ehe, tusaidie kwa hiyo swali ya kwanza.
Which two ICMP message types are used as part of a successful team? I would like someone to answer that. Nimeingia a bit later.
Oh, okay. Hey. So can anyone assist in answering that question? Yes, Gibran.
For that one, for the two ICMP message types, I believe it is the echo request and the echo reply.
Yeah, very correct. Thank you. Next question, Lynn, you can read for us the next question again.
In the event that the TL value in the IP header of a datagram reaches 0, what action will be taken by the receiving gateway?
You've lifted up your hand.
I think that one, I can answer that one.
Yes, please. Go
You
ahead.
said something about when the TL value is 0, the router sends back the message is unreachable or something like that.
What else does it do?
I think that message is discarded to avoid the network congestion.
Exactly, to avoid loops, which will cause congestion. But before discarding, what does it do? What Lena said, it will send the error message to the source. So don't forget that. Okay, thank you very much. We can, I think, now go to the next topic.